what are dependent types? And I would say that dependent types are a more expressive type system in programming languages used to catch a larger class of errors at compile time. So the typical example of a dependent type in action is the ability to declare in the type signature that the output string of a concat function should be the sum of the lengths of the two input strings. What would be typically assertions at runtime can now be caught at compile time.
In previous episodes, we've talked about how AI agents could be self-negotiating by reading documentation and understanding the semantics of the system. But here, I think maybe dependent types. If you had some type of dependent typing that could be exposed at a protocol level, then that could also simplify things.
Hi, this is Will. I'm a YC alum and an independent researcher who's worked across e-commerce, cryptocurrency, and financial industries.
And I'm Sri. I'm a YC alum and a research engineer focused on natural language processing for search.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it, an optimistic look at the road ahead. We're two guys discussing edgy, fringe, or overlooked technologies over a couple of drinks. Our show has 4 segments. First, we give a high-level outline of what the technology is. Second, we talk about what it can do today. Then, we let our imagination and optimism take over and see how the world would change if the technology was readily adopted everywhere. And lastly, if we believe in this future, how can we take a position on it? We can't be experts in everything we cover, so if you got insights on the topic, let us know in the comments. And be sure to check out our audio versions on Apple Podcasts, or Spotify, so you can go about your day as you listen. First, in the spirit of kicking off our discussion, what are we drinking today, Sri?
I am back revisiting Poppy brand. This time I have the Raspberry Rose. It's a prebiotic soda. Let's check it out. Yeah.
No, I am on my hard seltzer. I got a White Claw. Never had it before, but it's tangerine flavor. Spiked sparkling water. I had some earlier, but it just tastes like sparkling water. It's hard to believe it's like 100 calories. It doesn't. Yeah.
You're hardcore. You're too hardcore to taste the alcohol.
Yeah, too hardcore to taste it. So, are you excited about this week's topic, Sri? We're moving on in a different direction this week.
Yeah, this is a fun one. I'll let you actually introduce it, and then I'll chime in.
Well, so this week we're talking about dependent types. So, as always, what are dependent types? And I would say that dependent types are a more expressive type system in programming languages used to catch a larger class of errors at compile time. So the typical example of a dependent type in action is the ability to declare in the type signature that the output string of a concat function should be the sum of the lengths of the two input strings. And so you can also use dependent types to write functions that only take, say, non-empty lists or strings that are well-formatted email addresses. Because currently with typical type systems, you can't really dictate the length of the list, right? And so dependent types let you do that. And would be typically assertions at runtime can now be caught at compile time. So what I've said so far, does that make sense, Sri?
Yeah, it does. It's kind of crazy, though, because I mostly work in code bases in the past that didn't even have any types. And slowly but surely, I think in the last couple of years, people have been adding optional types to dynamic languages. But this is even far beyond what many advanced languages like Haskell even have.
Right. Actually, people think of Haskell as this weird out in right field, completely off in the distance sort of language that most people wouldn't know a lot about, and they use odd terms. This is even a step further than that. And there aren't that many mainstream languages that actually there are no mainstream languages that have dependent types. I've seen blog posts that hack around it, but they're not fully supported in any mainstream languages. So like I'll talk about some of the languages that do support them later on, but unless you look into or dabble in this sort of stuff, you probably wouldn't have heard of any of them. And I guess that's why we call this the Tech Team Podcast, where we talk about the edge of technology, right? So
yeah. It's really crazy though, because basically what you're saying is that we're blurring almost the distinction between runtime and compile time, because even if you are familiar with types, there are two phases: the compile time, where there's the type checking, and then there are these runtime properties. And you can't usually do things like inspect the values that are the inputs to a function or an output of a function and do some checking on that until you actually run that program. But here, what you're saying is that with dependent types, you can, because like in the example of concatenating two strings and making sure that the length of the output string is the sum of the lengths of the input string, that requires some knowledge of it, like its inputs and the behavior.
Yeah, that's
the runtime
right.
behavior.
And so I think that one good way to think about it is that in any programming language, there are types and what people in type theory call terms. And essentially, you can think of terms as just expressions. An expression is just a compositional combination of constants, variables, functions, and so on and so forth that, when put together, return a value. And so that's as opposed to a statement, which is more like the imperative paradigm, where you call a statement and some side effect happens. And so programming languages have types and terms, and typically, like, the work that you do with types is almost like on a separate level or a playing field than the terms and expressions, right? Because you have your type declarations, and oftentimes they don't really mix with the actual computation or implementation that you're doing. You typically think of them as two different things. But just like in functional programming, functions become first-class citizens, where you can pass them into other functions and then pass them around as values. Here, types can now also be values that you can operate on, pass around, and you can do operations on them. And so that's kind of where the line between types and terms start to blur, so that you can do certain things at compile time to do what typically would be runtime assertions and checks.
Yeah, and the cool thing that I've seen in a couple of languages, and maybe you can list what some of these languages that have dependent types are, but at least in the sample of ones that I've taken a look at, it's the same language that is used for both code that operates on terms and code that operates on types. Which is different than, I think, many other languages where, like you said, there's a special type language or type annotation system or something, which doesn't use any of the features and functionality of the actual language that you're writing your logic in. I think the closest thing that I've seen maybe in a mainstream language is something like Zig, which allows you to do comp time generation of types. But the difference there is that with dependent types, you can actually access it.
It's funny that we call Zig a more mainstream language on our podcast, right?
Yeah, it's true. I mean,
but yes, go on.
I think the difference with Zig is that Zig has uses the same language in its comp time pass as it does during its runtime pass, but it's not able to access the terms, the runtime variables, in the same namespace as the comp time variables. So that's the difference there.
Yeah, I thought dependent types were a really interesting take on the direction that types can take programs, because I know that a lot of times you try to write a program and you're just not sure if it will work at all or not. And we developed all sorts of cultural practices and behaviors and rules of thumb to help mitigate it. And dependent types are one of the few instances where programming has turned to math to try to solve some of these things. And I guess it's strange because programming was rooted in math, but for a variety of reasons, we've kind of moved away from it. And dependent types would be something where I guess it's like going back to the roots. Like it's like if we were the programming was the Beatles, it would be like, I don't know, whatever album they did to go back to their roots. I wish I could name it, but I have no idea.
I see. Yeah.
But and so I think that's kind of the one interesting part of it.
Can you give some names of like examples of languages that have dependent types?
Yeah, ones that specifically support dependent types are Agda and Coq and Isabel, and these are more well known as proof assistants and people that are working in type theory, and they're basically mathematicians that want to do mathematical work in proofs with languages and denotational semantics and stuff like that. They typically work with these languages. For people that are more, I guess, more practically orientated, whatever that would mean in this context, they've turned to Idris. What's another one? F star. Although I haven't looked too much into how F star is different from the other ones. I've seen blog posts where people have hacked the existing type system in Scala and in TypeScript to do parts of what dependent types are able to do, but I don't think all the features of dependent types languages are fully supported in these other languages that you kind of hack things into.
I see. So this is what you mean by returning to its roots in math, in that this exists in languages that are even more obscure than like Haskell, which I think many people already consider very obscure.
And Haskell doesn't natively have dependent types, although there are plugins and libraries that help it use dependent types in Haskell. But if it's any indication, like I looked at Agda and Idris, the syntax pretty much looks like Haskell. And is Haskell in the ML family of languages? I don't remember.
I don't know.
But yeah, like that all looks fairly familiar when I was taking a look at it.
I see.
If you if you can read Haskell, then Agda and Idris will look pretty familiar.
Yeah. Why do you say that it's related to math?
I think that's an interesting question with a answer that was surprising to me the first time that I heard it. There's a talk at Strange Loop 2015 vintage by Philip Wadler where he gives a talk called Preposition as Types. We'll put it in the show notes. But in it, he talks about the Curry-Howard correspondence. And the Curry-Howard correspondence is kind of an observation or a rule, I guess a rule of thumb, an observation that it seemed like any good idea in logic, in math, was independently rediscovered in computer science and vice versa. So apparently there's some sort of duality going on between logic and computer science. And so, for example, type schemes were discovered by Hindley in 1969, and then Milner later on in 1975 put out a paper on the ML type system. And so these ended up to be equivalents of each other, and all the type systems of functional programming languages today are based on this ML type system. And similarly, there is a duality between the mathematician logic world of modal logic and monads in the computer science world. And so you'll see this kind of duality between logic and computer science, to the point where you can say that in logic you have prepositions And the equivalent in computer science is that they're types. And then in logic, you have proofs, and the dual of proofs in computer science is programs. And then in logic, the normalization of proofs is equivalent to the evaluation of programs in computer science. So there's this kind of like odd correspondence between logic and computer science. And Philip Wadler calls it Curry-Howard as a double-barreled name that generates other double-barrel names. So that's how you get the Hindley-Milner type system, stuff like that.
Yeah,
and
interesting.
And it's I liken it to almost like a periodic table, where one of my big pet peeves about the internet is when somebody puts up the periodic table of X, where X is something that is not about chemistry, say like interior design or infographics or something like that. And so first of all, their periodic tables are never periodic, and two, there's no predictive power, right? Like one of the things about the periodic table in chemistry is that you can see where there's like spaces and holes in which an element should be there, but we don't know what that thing is. And so you can go figure out what that is. And so I would say that Curry-Howard correspondence is kind of like the periodics table in the sense of its predictive power. Like if you have something that we know in logic in the math world, then there should be some sort of correspondence in the computer science world and vice versa. So the idea of dependent types comes out of this work that mathematicians and logicians and computer scientists have been doing on type theory. And that's how it relates to math. Because one of the things, so anyways, before I move on, does that, was that something that you found in your research as well?
Yeah, I thought that was interesting. And the way that I see that it relates to dependent types is that even with this Curry-Howard correspondence, you have these sort of proof systems or logic, like you're saying. And I think maybe it's useful to think about logic as some set of rules in which you say, well, if this and A and B are true, then it follows that some other properties hold, right? Like this is what a proof is. And I think what makes dependent types interesting is that it almost unifies the two. Like if you have a program, you can get a proof out of it, or maybe vice versa. Versus, I think typically those two things are separate, right? Like you have proof proof languages and normal languages that you use to write programs, and dependent types unify these two.
Yeah, because like in our TLA plus episode, we talked about TLA as a language for the design of protocols, and it's like a kind of proof system, right? You can do formal verification on some sort of algorithm that you're working on, but it's still up to you to translate that formal specification into the implementation language that you're writing. And mistakes can occur there. But the interesting here with languages that have dependent types is that the program is the proof.
That's pretty cool, because that means you don't have to write the same thing twice.
Yeah, and so I think it holds a lot of promise, and I haven't used it in full. I've played around with it a little bit, and there's some affordances I thought were interesting, which we'll get into later. But I think I'm cautiously optimistic here. And the other aspect about how dependent types relate to math is interesting in that there was a mathematician whose name escapes me at the moment, laid out the possibilities of different type systems that you can have in a programming language into something called a Lambda Cube. And the reason why it's a cube is because there's different combinations of how types and terms can interact with each other in a programming language. And so at the bottom left corner of this Lambda Cube is the simply typed Lambda calculus. And it's like the basic Lambda calculus that we know and love with simple types. And the different things that you can add to a programming language's type system is how you can convert from term to terms, which is functions, right? Functions are something that you put in terms and you get out terms. And then you can do types to terms, which is polymorphism, or types to types, which are what we call generics. And then the last missing one is called terms to types. And so you can have different combinations of these sort of features, and they give you different type systems. And so the Lambda Cube is a way to categorize and organize kind of the progression of weak type systems like the simply typed Lambda calculus all the way up to what is called the calculus of constructions. Very fancy, up in the upper right-hand part of the cube. And so I think that's the other thing I wanted to mention, just for people that wanted to go dig into this a little bit further, about like how dependent types are like kind of related to math, and it's the time where programming turns to math. Because I think typically it's something that really surprised me about programmers is how allergic a lot of programmers are to math. You would think, but that's totally not the case.
Yeah, I mean, some programmers are very, very into math, and the other set of programmers are very allergic to math and notation and things like that, which we've touched upon. And I think it's an interesting conflict that we can go into in terms of what it would take to get dependent types into the mainstream. But yeah, we can touch upon that later.
Well, we all know what the answer is. Build a $1 billion company, and when people ask you, how'd you do it? You say dependent types.
Dependent types, yes. Exactly.
So one thing that I wanted to move on is kind of a sketch of how it works, because I think normally we don't do too much of like how a particular technology works, but it does seem a little magical that you can check the runtime properties of a program without running it. That seems weird, like when you say it like that, right? But in fact, it's not so weird when you understand that the terms and types are kind of mixed together. And so when they both are first class values that you can intermix between each other, then that means that you can assign a separate type to each number, right? Because typically we say like the numbers 0 through, I don't know, 2 to the 32 are all ints, for example, right? But with dependent types, you would be able to give a different type to each number. Does that make sense so far? So
yeah, I mean, that sounds kind of crazy, but yeah, that does does make sense.
Right, that sounds crazy, right? The number 2 has type 2, and so on and so forth. And so that also means that you can now assign a separate type to a list of different lengths. And so for all lengths possible for a list, so you can say a list that has one element in it is a type of list of 1. A list of with 2 elements in it would be a type of list of 2, and ad infinite. It sounds crazy, but like we have compilers to manage this sort of stuff for us, and so you don't have to write this sort of stuff by hand. And so I think the thing that gave me the aha moment was that with this setup, I could see now that the value of a term is now encoded in its type. Does that make sense? Like the type is now more fine-grained to encapsulate just one value. So the number 1 has a different type than the number 2, even though they're all ints. So it's kind of like the type is now dependent on the term of a different type. So it's kind of like now we can define the length function that will take one of the above list types and then have a dependent return type of 1 for the number 1 for the type that is for the list of 1 element. and so the to type for the list of two elements type, and so on and so forth. And so at compile time, when concat is being compiled, it can inductively prove and check that the lengths of the input add up to the lengths of the output. Because remember, the length of the concrete instance of the list type is encoded in the type as a list of three elements. Does that make sense?
Yeah, it does. So basically, you're tracking some properties beyond simply that this is a list, which is a container or something like that. You're also tracking potentially the length or other invariants about the data structure.
Yeah. So that's kind of how I understood it. And it sounds crazy, but I guess you can do crazy things when there's a compiler to kind of handle it for you.
At face value, it seems like this would just blow up in terms of the number of types that it generates. But I guess there's some magic optimizations that they're doing so that this is a tractable problem.
My take is that it's probably lazy. Like, in order to prove the set of natural numbers, like, you don't need to have iterated through the entire set of natural numbers. Like, you can set the base case and then the inductive case, and then that should be good enough.
I see.
And I have to say that, like, I am not a type theorist by any means, and I don't think Sri, neither are you. So if you, as the viewer, has other things to add to our description of dependent types, then by all means let us know down in the comments, and we'd appreciate it. And if we get enough things wrong, we look forward to a dependent types part 2, I guess, right? So
yeah, right.
Exactly. Yeah, so I think moving on to the next segment of our discussion, I mean, like, the interesting thing is, like, now that we kind of cover, like, what this thing is, like, what are dependent types, like, what does it let us do that's new, like, what are the new things that you can build? Like, I mean, I think there are the obvious things that came up. Basically, like, you can do compile time checks that normally would be runtime assertions, and so you can build programs that are correct by construction, like that are correct and that check themselves. I think there are probably other things, but I was wondering if you saw anything in your research or travels on the internet for, like, what's it let us do that's new.
Yeah, I think it would be helpful to enumerate some of the interesting use cases for dependent types that are a little bit more concrete.
Yeah.
I think that some examples besides the like lists that know their own length at compile time are things like asserting that some value is positive and remains positive throughout the lifetime of its existence, or a string. Let's say that you want to put something into a database, and it I don't know, the column has some cap on the length of its input. So you might want to track, like, a string is at most n characters long, or you have two values and you want to keep track that one value is always greater than the other. That's some kind of invariant that you want to maintain. And so basically, I think this connects to an article which is titled Making Illegal States Unrepresentable, in that dependent types, and typing in general, but I think dependent types, what they allow you to do is make certain things that you would have to actively check for, usually in, like, lesser programming languages. You'd usually have to check that some properties are true of the system, right? Like, check that this integer is not null, check that this thing is positive, et cetera, et cetera. And now with dependent types, what you can do is actually relax, or you can get rid of that kind of checking at runtime and push those types of things to the type system, and it would prevent those the variables or those terms from taking on those illegal values, almost by proof or by construction.
Yeah. So then, playing the devil's advocate, then, like, why would I want to use that if I can specify invariants with database constraints. Like, Shri, why would I use this? Like, I have checks in my ORM. I have constraints on my database. Like, why would I do this per se?
Yeah, I was thinking that too. But one most compelling argument that I heard is that proofs compose. So logic at mathematical level composes. And so if you wanted to test all properties of your system and all invariants of your system, there would be this combinatorial explosion of things that you would have to check for. So, for example, if you wanted to make sure that some invariants held, you could write a lot of unit tests. But then let's say that you have more than one invariant that needs to hold. You'd have to write a lot of unit tests that potentially exercise all combinations of those invariants to make sure that for all combinations of inputs that the outputs are valid, for example. And to give an example, I think I was writing some code recently for work in which I was adding a new code path that would sometimes modify some of the logic that was being run. And there was an existing test suite. And I had written another, I think, 10 or 20 unit tests for my code path. And then I was faced with this inkling of a doubt that, hey, like, what if there's some weird interaction between like when my logic runs and all of the existing unit tests that are there? Like, should I rewrite all the existing unit tests that are there, but with my that exercise my code path? I don't know if that makes sense, but basically, but like I couldn't assert for sure that whatever I was exercising or whatever logic I was adding wouldn't change the invariants that were already being asserted, because those things don't compose. Whereas I think with dependent types, you don't have that worry, because basically it verifies the whole program as a proof rather than simply leaving it up to you to check assertions through all valid code paths in your program.
That sounds really compelling, which makes me wonder if you can do better DevOps through dependent types. Because I guess one of the long-running themes of this podcast is where almost every episode I rant about how I dislike DevOps, because it's just a collection of arbitrary configuration files and declarative programming languages with settings that can break arbitrarily. And like, I never like learning any of that stuff, because I feel like they're not concepts I can take with me. And so I'm always loath to mess around with it. But maybe with dependent types, you could get something that like a DevOps developer experience in which you can take things with you and you can like have composable things. But I guess that we might want to leave that to a second and third order effect discussion. But in the near term, I did see a tweet by the author of Idris, a programming language that has dependent types, where he's like saying that he was trying to compile Idris itself, and he had forgotten some sort of environmental variable that he had to change, and it wouldn't compile because the environment variable was wrong. And he's like, oh, okay, that's great, because I would have deployed this thing and the environmental variable would have been wrong, and I would have had to like debug this, trying to figure out what the hell happened. But like, it can catch like dumb like configuration settings like this, and that's one of the nice little benefits that happen when you use it, as opposed to the toy example of the vector lengths, which I think is not indicative of the value that you would get from dependent types.
Yeah, I thought that was really cool. I actually was curious how that worked, but that is a very practical thing, right? Because most of the time, I think the
Yeah.
gap between this like math stuff and the working programmer is that it's pretty rare for people to have these very abstract invariants that they're maintaining throughout their programs, because usually you're working at the level of business logic, and there aren't a lot of like strong invariants there. There are some constraints that you have to maintain.
Well, I would say, yeah, it may depend on the domain. I can see how in financial software or like things where like you're dealing with people's monies, there's some type of constraints, but I would imagine that it's not as apparent because most of the programming languages and tools that we have, the constraints are often expressed as if then else statements rather than declarative constraints. And so it's not nearly as apparent. I would argue that they are actually there, but like they're all just littered all over the place in multiple nested if then else statements.
That's kind of true, actually. I wonder then if in companies where there's a strong like separation of roles between product managers and engineers, where product managers or project managers or whoever are mostly dealing with things like setting up the business rules, defining the business rules and the business logic, and then they hand it over to engineers who code that up, whether that's an avenue to make dependent types more popular, because then you can go to the project manager and say, hey, I have a way for you to encode all the rules that this thing must have, and you don't have to worry about doing like so much QA and validation because you get this for free. Just specify like what stuff must hold.
Yeah, I wonder because like this attempt has been done before with test suites like Cucumber, right? Like Cucumber made like English sounding tests, and presumably PMs would be able to write Cucumber and to be able to specify stuff. But I get the sense that it's not very widespread in industry. They still just have meetings. Like people get people in the same room, like PMs, designers, and engineers in the same room for a meeting, and then figure out that the other parties that they actually need in this meeting are not in the meeting. So then they postpone the meeting for another week and so on and so forth until they manage to get everybody in the same room. And then they kind of hash things out and then throw it over the wall to the engineers. I don't get the sense that tools like Cucumber are used that much. And so that's why I'm a little hesitant to say that dependent types will make it over as a PM tool. But that said, maybe it's something where engineers can show the resulting dependent type signatures to a PM to say, hey, is this what you meant? And they would be able to find it very readable. They may not be able to write it, but they would find it readable to say, yes, this is what I want. Right? Maybe it's something like that.
Oh, like a kind of report. Like a human readable report that maybe the compiler says, okay, here are the
here are the invariants for the business logic part. So maybe something like that would be useful and interesting for people in industry. Like, do you get the sense that Cucumber is like widely used in industry? I didn't get the sense. So that maybe like for like Cucumber is in the world of Ruby. So I don't know.
Yeah,
I don't know. You tell me.
No, I don't know. I to be honest, the only time I hear anybody talking about Cucumber is on this podcast, and I think us on Twitter. There seems to be something compelling about the idea that you can align across different roles and functions. You can have some standard specification language that aligns expectations with implementation, right? The specification with the implementation. I think we're chasing this thing, and I think it seems like dependent types are a powerful tool, right? Because they unify specification and implementation. But I don't know. I haven't seen anybody use. People hardly even use Cucumber, and this is even more futuristic than that.
Right. It's about time. Like, we were doing a lot of retro episodes, and it's about time we talked about in the far future. But actually,
Right.
dependent types have been around for a while. It's just these sort of ideas take a long time to permeate. So, like, in a sense, in the timeline sense, dependent types have been around, I want to say, in the early 2000s or something like that. And so it's already like 2023, and there's still no mainstream languages. Like, mainstream languages are still dealing with the option monad, right? So
Right.
yeah.
Yeah.
So I would say that that's the case. But maybe I mean, like, PMs work in Google Docs or like some sort of like document. So maybe with the advent of ChatGPT, they can conversationally come up with a written specification that then gets translated or formatted as a dependent type specification that then the engineer takes and runs and verifies that the ChatGPT did things correctly, or that's what we actually want. So maybe it's all possible.
Yeah, that would be cool. Yeah, the other thing that I wanted to talk about actually for why dependent types might be superior to other traditional methods like doing runtime assertions or unit tests or something like that is related to this article, which I think is fairly popular, called Parse Don't Validate. Basically, the idea...
We'll link to that in the show notes.
Yeah, we'll put it in the show notes. But basically, this post is making the distinction between validation and parsing. Validation being simply checking that something is true and then passing the value along if it's not, or erroring out if it's invalid. And then parsing, which is basically adding structural information to some input, right? So if you think about JSON or something, like if you parse a JSON string, then you're actually taking that and adding some structural information and making that into a real data structure or something like that. And I think that dependent types are an application of parse don't validate, but for type checking, in that what happens is that as you go into the depths of your program, you're able to keep track of more and more useful things. So if you pass like a string or something into a function in a dependently typed language, then the type system might be able to keep track of certain invariants that now free you from having to keep checking that everywhere down the line in your program.
Yeah.
And so it actually saves you some hassle. One of the problems with regular types is that at a certain point, they just become like boilerplate, because there's nothing more fine-grained than just a string or a list or this class, that class. They don't actually help you know that, oh yeah, this list came from this place, and because it came from this place, I can rely on the fact that it, contains at least one element, or it has been sorted at some point,
right,
or whatever.
It's got this order or something.
It's got this order. And so I think that's the one annoyance that a lot of people, that put people off from doing typing in like languages that have optional typing, is that at some point it just becomes like they're very quickly like sort of you run out of information that you're getting from the type system. Whereas I think here, like the type system is rich enough that actually it's helping you more and more.
Yeah, I think it depends on like how you treat types, because I know that Rich Hickey, the author of Closure, famously eschews types for Clojure, which he also considers a functional programming language, but he means functional in the immutable sense. Like he's just says, I understand the sentiment that oftentimes when you're like dealing with types, it feels more like a puzzle that you have to do in addition to the work that you're doing.
Mm-hmm.
It's kind of like, is the implementation not hard enough? Here, solve a Rubik's Cube at the same time that you're doing some work. Yeah. And I can see that. But then on the other hand, I do know that sometimes people that have been working with Haskell for a longer period of time, they design all their types up front first. So then types and the type system become a design tool for them, and they get that right first before worrying about the implementation. And so in that sense, I can see how it's a help rather than a hindrance. So back to your point about like what that boilerplate feels like. I think that boilerplate feels like if you don't end up using types as a design tool, and mostly it becomes like when you don't use it like that, then the compiler becomes a heckler, like just sitting around telling you that you're doing things wrong. And it feels terrible, right? Because like in dynamic languages, you type some stuff and you just hit run, it'll, for the most part, do something. Like you may not realize it's wrong, especially in things that are like concurrent distributed programs, but it'll run. And so you get that immediate dopamine hit of something running. Whereas like in typed systems, it just feels terrible because it's just one compiler error after another. And you have to like wade through like sometimes hundreds of them when you like refactor something. And on one hand, like you can refactor fearlessly because you know that once you get through all the errors, if it compiles, it'll probably run and be correct for a large number of cases. But man, does that experience suck? Like every time you're just like, getting punched in the face over and over again by the compiler. So yeah, I understand that kind of the sentiments from either side. And so for you, like how does this relate again to kind of like the validation versus parsing?
Oh yeah, just basically dependent types are doing some type of parsing, at least as this blog post is defining parsing as once it runs through the parsing function, the thing that comes out the other side is enriched with some metadata, basically.
Yeah. I think that's also a good way to look at it. That like you have like other information besides the familiar in spools and lists, like in addition to do stuff like that the compiler can do stuff like metadata that it brings along with it, right?
Yeah, exactly. And so I think that just knowing that something is an int and a list and stuff prevents certain types of issues, like you swap the order of arguments and whatnot. But I think the reason why it's a sort of a hard pitch to make to people who are averse to types is that they can just say, oh, well, I'll be careful, right? Or I can see based on this, call site here, I haven't switched the order of these arguments or forgotten an argument or whatever. But I think with dependent types, it's harder to argue against it because the richness of what it knows is even beyond maybe what you would be able to just naively reason about by looking at the code. And so it is it becomes more of an assistant.
Yeah, I in terms of an assistant, did you try programming in any of the dependently typed languages?
I followed the tutorial for Learn You and Agda for great enlightenment, but it's very light on the details, so I didn't get a feeling for what it is.
I played around with Idris a little bit. I installed it and I installed the Vim syntax highlighting package for it. And it was kind of interesting in that you could write out the type signature and then tell Idris to fill in the blanks. And so kind of like in Idris, you can put in holes. Like you're saying, I know something should be here, but I don't know exactly what it is. Like, like you know that there should be a placeholder here. I don't know what it is. And then in some cases, like when you say, I don't know exactly what this is, you can tell it to like split out all the different possibilities of what it could be. So for example, something could be like a list and you split it out. So then it'll write out the different pattern matching cases for it. So like one case could be the empty list and then the other case is the head with everything else behind it. And so you can kind of like ask it to iteratively search through the proof search space to give you something that makes sense. Because sometimes there can only be one thing to fill in that hole, but instead of writing it yourself, you just ask for it to give you the most obvious proof, or do a search through the proof space to give you something. And if there's more than one, then it presents the options and it picks it for you. And so everybody is really excited about Copilot with like the AI auto completion sort of thing. But like this is kind of similar, but it's got math behind it. Like like it's that similar feeling that the programming language environment is helping you out, and so all you have to do is like check and read, but at the same time you have the feeling that this thing is correct because it's based on math, as opposed to ChatGPT where you have to still play computer based on your reading of whatever ChatGPT or like Copilot gave you. And so it's a little different in that sense, but I was surprised by that experience there.
That's actually really cool. Yeah, it does seem like Copilot in that you're basically asking it, hey, what are my options here? And then you're now selecting among them rather than having to generate them all yourself.
Yeah. So I thought that part of the experience was pretty cool. And I guess it also reminds me of a little bit of like what the semantic web thought it might be, right? If everything was well structured and connected, then you could do searches by joining and concatenating and reducing all the intermediates all down to the same thing. It's kind of got that same feel to it, except this actually works because the universe is much smaller, right? Like you're not relying on humans to populate web pages for the semantics, which they're prone to lie about. This is a contained universe, so that you can actually rely on the traversal of the proof search space to give you something that makes sense.
Yeah, that's cool. I think one concrete use case I can think of is when doing some type of refactoring or something where I wonder if in a dependently typed language you can run queries over the program that say, find me all of the places in this program where this thing is true, where I am relying on the fact that a list will not be empty, or I don't know, some other invariant. I'm expecting that some invariant is true, and then let's say that now my logic has changed such that that invariant will no longer be true. Then I can easily change that and find all the places that are affected, and the compiler will maybe help fix that or add a check or something like this.
Yeah. So I think that's something that I haven't really seen a programming language do. And so now that GPT and Copilot is getting everybody's attention, maybe that'll help people recognize this affordance once dependent types get a little bit more popular. Maybe. Yeah.
Yeah. You said that there was some dependent type thing in TypeScript. How powerful is that, or is it like pretty toyish?
It's toyish, and it's kind of like a hack on the existing TypeScript type system. And so they were able to do basic things, but I don't think they had the full power of all the other things that dependent types were able to do. So basically they were able to use like type constructors to put metadata in it and then be able to do operators when they constructed new types and use those new types as types that you would use in your function type signatures. That was a lot of words. I don't know if that made sense, but basically, it's more verbose. Like it's kind of like if you implemented FizzBuzz with C++ templating language. It's kind of like that.
I see. Okay.
But we can put it in the show notes. But yeah, like it's definitely kind of possible. Like I've seen another one. There's another talk which we'll also put in the show notes where the the author of Idris is showing off dependent types, and then he has a co-presenter which tries to show the equivalent in Scala by hacking Scala's type system. And so for some of the examples he could reproduce something, but for others he's like, I got close but not quite. So it's kind of like that.
I see. Okay.
So in summary, I think the dependent types gives us a way to actually have programs that are provably correct, which is something that we didn't have, I would say, for a long time. And we've leaned heavily on unit tests to get us through the day, because otherwise none of us would really sleep, because our systems would be going down all the time. And then we would wonder, like, which one of my idiot coworkers did this to me so that I can't sleep, right?
Right.
And then you do a git blame and you find out that it was you. You did this to yourself.
Yeah.
So that's kind of like an interesting turn. And you would think that this would be more readily adopted, but I don't see a lot of attention here. Do you get a sense of like why that is? Is it because math is scary, or because it's just not in any of the mainstream languages so people aren't paying attention? Or is there not like a new platform that people see a lot of potential in? Because a lot of times like programming languages get adopted not really because of their features, but because there's a new platform that comes up and that language is the best known language for that platform. So that's how you get like JavaScript on the web, or like C on, I don't know, Unix like computers, or you get like Solidity, which is a terrible language. It's like people that hate programmers that, I don't know, I looked at the CV of the guy that designed it. It didn't seem like he had a lot of experience designing programming languages.
Yeah.
But then again, I mean, like, it's the same thing with the inventor of PHP. He was not a programming language guy, and I mean, it worked. Facebook runs on PHP, so what do I know, right?
Right.
But my point still stands, is that a lot of times the adoption of a language is based on the popularity of a platform that people want to write on. So I guess that would be my answer as to like why dependent types are not more popular. But it seems like this correctness thing would be really popular for concurrent and distributed systems, because or like something that's business rule heavy, like maybe in finance. But I don't see a lot of uptake currently with that. Have you found like a compelling reason why in your travels?
I found a GitHub issue thread that was in the F# repository, F# being the ML type language for the .NET runtime.
Mm-hmm.
And so there was a petition or some kind of feature request for adding dependent types to F#. And the creator or maintainer of the language chimed in, and he had a variety of reasons against it, but the big reason why he was against it was that it would add a lot of power to the language, and that power would be entirely within the reach of people who understood very abstract mathy things like category theory and such. And he was against this in that he was afraid that by adding this kind of power, which is only accessible and understood by a very unique subset of people, that it would really steer the course of the language away from being used in real production systems. And I think that's valid because even with a language like Scala, I remember that Scala was kind of taking off in the early 2010s or something like that. Like there was some interest around Scala, I remember. And I think a lot of the reason why that
Twitter adopted it as well.
Yeah. Twitter adopted it. But I remember that a lot of the interest around Scala very quickly became sort of self-absorbed in that like people were just making like libraries that were more and more esoteric and more math-like. And so I think that to answer your question, why is this not more popular? I think right now it still very much looks like math, and the languages and the design of those languages seem to favor people who have had some formal training in mathematics. I think that what would really make this more accessible is, I don't know, I feel like TypeScript did a very good job of taking some fairly advanced type system constructs like structural typing and bringing those to mainstream programmers, and almost, I almost say this every episode now, but like kind of like hiding the vegetables right in the food. Like you don't tell people that it's like based on any theory. You're just like, hey, here's this cool thing. And so I think
it just came to me. I was inspired.
Right. And so I think that that's what it would take, because I do think that, like you said, there are a lot of business logic. There are lots of places in business logic where, even though people don't use the word invariance, they are keeping track of invariance, right? Especially in financial applications and other applications where like correctness matters a lot.
Yeah, but I don't know. Like in some sense, I wish there was it's kind of like saying, well, it would cater to people that could read. And so we don't want, right, because like most people that are like running around are illiterate. And so we don't, instead of like trying to like helping them learn how to read, we'll like cater to their illiteracy.
Yeah.
And yeah, I mean, like in that sense, I mean, I can, once again, I think when it comes to a lot of issues, I'm kind of on the fence because I'm just taking the other side. Because definitely for me, even though like math doesn't scare me, like some of this like type theory stuff is pretty esoteric. Like I'm reading some of this stuff, I'm like, I don't even know how to look some of this stuff up because they're symbols. And I was just like, I don't know what to call this, and I don't know what to put in the search bar, right? It takes a little while to kind of figure out a lot of the jargon and stuff. But still, and so I definitely am on your side about the accessibility part. But on the other hand, I mean, I feel like math is something that is a powerful tool when wielded in the right situations. Like it's not a panacea, of course, but it's kind of like yeah, like giving people the power to do something, having it available, having it appeal to people that are literate. I don't know. Maybe if it drives the people that are illiterate away and it's all the illiterate programmers that are piling sand. I mean, I don't know. In some sense, it's true. Like, yes, you do want to appeal to the people that are doing a lot of the work in the world. But on the other hand, I guess you could compare it to like maybe the other analogy are you don't want to appeal to people that have an understanding of material science and mechanical engineering because it'll drive away the people that are building pyramid like buildings. So instead of like designing skyscrapers, like you just pile rocks on top of each other to build it high,
Right.
you build it wide, sort of thing. And in
Yeah.
some sense, that's kind of what we do, right? Like we don't write programs that are provably correct, sometimes for good reason, right? Because it takes a long time to prove something is correct. Like you have to be willing to put in the work with the right payoff at the end. And so what do? We just hire legions of programmers to just fix it when it breaks. And
Yeah.
that's how we do things. And it's really, I think the analogy to having legions of workers building pyramids, it's kind of like that. Like, would you say that that's the case? Because like I think
Yeah.
people that are not in tech would be surprised at this is how it works, because you can see evidence of this at Twitter. Like Elon Musk comes in, fires a whole bunch of people, and like I notice like cache inconsistencies on the app all the time.
Right.
I
Yeah.
mean, maybe it doesn't matter because I'm still using Twitter, so maybe those people didn't need to be employed in the first place, so I'm still
Right.
using it. But yeah, I guess that's kind of like my I would say,
Yeah.
I don't know, it's a balanced view, I guess, right?
Yeah. I think that I think the maybe the the intermediate take of this is that it's not that people don't want correctness. I think that one of the reasons why even just basic type systems have begun being taken on in, let's say, Python or
Yeah.
JavaScript / TypeScript is
Mm-hmm.
that it was optional, and the ecosystem gradually bought into it. And the way that it bought into it was interesting because a lot of the time, the earliest adopters of typing were authors of popular libraries, because there was the sense of responsibility that, hey, this is a dependency, this library is a dependency for many, many other things. And so let's do this right. And at least within the scope of, this one library, and then maybe the code that immediately interacts with it, we can get some just better correctness, right? And eventually, I think more and more library maintainers did this, and then that improved a lot of correctness in the sort of the lower level dependencies. And then I think companies started to see the benefit of this and started to incorporate typing into their business logic and their code base. And I think that's probably a better vector by which to get people to buy into correctness. And I think similarly with dependent types, I could see that there is a lot of value in certain places. I think, for example, configuration languages or configuration DSLs, like you were talking about, could make use of dependent types to, like you said, prevent illegal states. Right? Like a lot of the time, people are configuring their things in just random JSON files or like YAML files or whatever, and you have no idea whether you've written it correctly until you like do whatever, like kube control deploy or whatever, and then it's like,
right.
No, actually wrong, you got it
take
wrong.
It down, and then there's like you have to write like status updates on on why your system is down, that sort of thing, right?
Yeah, right. And so maybe some of those maintainers of those libraries can add dependent type checking on those config files, and you as an end user are not necessarily writing the type definitions or whatever yourself, but you do benefit maybe from the VS Code highlighting like, hey, actually, this is an invalid value, right? Like we expected that this would contain at least one number or something. I don't know, whatever. And similarly, I think for other libraries, like things that are doing, I don't know, I think parsing is a good one, where they're taking some data from the outside world and bringing it in as domain objects into your program. At that boundary, I think that's a good place where you can add dependent types and get some guarantees that, okay, once it passes through that sort of membrane or that barrier, I can expect that the object on the other side is well formed according to whatever constraints. And I would actually be really happy to use dependent types in that case, because it's not adding any conceptual burden to me if somehow the library took care of defining all those types, and I was simply able to benefit from the annotation that it gave me. So I think that it would, if there was such a thing as gradual dependent typing, maybe that exists, I don't know, then I could see its uptake being like more prevalent.
Well, I guess this is homework for our viewers, that like Philip Wadler does mention in his talks that some of his work is on gradual type, but I don't know if this is the same thing. Like there's all sorts of other type systems. Like there's session types as well, and there's linear types, which I guess we won't go to, but like I don't know if gradual typing is what we're talking about here. But like I think your point remains that there's a certain beachhead or foothold that you gotta get your kind of foot in the door, and usually it's a combination of the user needs in this specific time on this specific platform, that then things kind of like take off. And until then, you just kind of have to wait, like wait for that thing to kind of catch on, I guess, in these kind of serendipitous ways, because that when somebody decides to kind of take that on, right? Because Ruby never would have been popular without Rails, and Rails, DHH decided to build on Rails because it had some of the metaprogramming niceties that allowed him to build some of the DSLs that he wanted to do, but he could have just as well picked, I don't know, something like IO or Self. I don't know. But like there's other just as obscure languages as Ruby at the time in the early 2000s. So maybe.
Yeah. I think I have another few ideas for what it would take to get dependent types more popular. I think that one of the big industries that I've seen is booming now is cybersecurity, and it, especially because in the last couple of years, like almost every like random service or company that you interact with has had some breach or hack or something like this.
Yeah, I get a lot of notifications from, have you been pwned?
Yeah, and it's like, so it's just, at this point I'm just getting desensitized. But I can imagine that I could see that the EU, in the similar vein to GDPR or whatever, might impose some type of regulation. Let's say that they were to impose some type of regulation that would put the financial burden of those breaches on the companies that end up getting hacked. Then security, getting the security invariants correct would become very, very important, because a lot of the time, if you read the postmortems or whatever of these hacks, it's something to do with like some very like the code didn't maintain some invariant, right? Like, once you got access to one part of the system, the rest of the code just assumed that you were sufficiently authorized to take some other types of actions that actually you didn't necessarily have the privilege to, right? And so I think that security, those kind of security rules could be expressed as proof, right? Like you want to maintain that this user object has this privilege. And when at this point in the code, this user object, I want to know that they have this privilege because something up the chain has checked it. And I don't need to keep checking it or just assume that they have it. And so I wonder if there's...
you don't even need to have that boundary because like the type would be prevalent throughout your program. So anytime you use that type, it would get checked.
Yeah, right. So you get it for free, basically. That like, okay, at this point I can safely assume that this user object, because that it has this type, I can let it do X, Y, Z. And so I wonder if there will be a move towards having more provably correct security systems. And in that case, I think dependent types could be very powerful because they can express all types of different invariants that, like I think security a lot of the time can be expressed as like ACLs and privileges and users having certain roles and whatnot. And I think you could encode that in a proof-like way.
Yeah, I think so. But then I guess the flip side of security is always convenience. And so would dependent types feel like onerous or overbearing because like it's hard to satisfy all the environment or all the invariants when all you want to do is add two numbers together, but like you can't get it to do it because like you can't find all the ways to satisfy the invariants or something like that? Or could you have like conflicting invariants? Like would that just not compile? That's my guess.
Yeah.
Like if you have conflicting, something like that. Well, I know that one thing, like one concern that people have is that if you have such an expressive type system, like would the type checking never terminate? But I think that's actually false in that like these dependent type systems do actually terminate. I don't know what the mechanism is, but like you won't end up in an infinite loop or anything like that. Probably because there's something they limit for it. Maybe like they limit the type of negations that can happen, perhaps. Like you can't say like this thing cannot be something rather than this thing has to be something. Maybe that's my hunch. But anyways, the point is like, I guess my point is like I wonder if the flip side of this is like the convenience aspect for like the security, but like barring that, it seems like it should make sense because then you do get it for free every time you're using the type throughout your entire program. Plus, it's all done at compile time, not at runtime either, right?
Right. Yeah. I think that there would have to be some other
that slowdown if people are worried about speed or anything like that.
Right. Yeah, I think that people are not at this time thinking about provably correct security, probably because the stakes are not very high to the people who write the program. Like, you get hacked and you get on Have I Been Pwned or whatever, and you get an email saying, we'll give you 1 year free like credit monitoring or something, right? Like some trivial penalty.
This is not true of cryptocurrencies. So I mean
right.
The Philip Wadler, who I mentioned before, like he works on this like type theory stuff. He consults for what is it company? IOHK. They're like a cryptocurrency company, and they try to have provably correct programs and smart contracts. Because I mean, like on Ethereum, like Solidity is just so easy to like shoot yourself in the face. Not even just punch yourself in the face, but just shoot yourself in the face.
I see. Cryptocurrency is a very good use case, because you can't reverse it. You can't reverse any of these things once they happen. So you better be sure that it does the thing that you want it to do.
Yeah. So maybe, but then I guess like cryptocurrencies people have to believe. I mean, crypto is down at the moment of this recording, But I mean, if people believe again, and if it finds its place among the financial system, which I think it will. It's been a while since we've done an episode on any crypto stuff. Maybe we should do
Right.
that. But yeah, I think it definitely has a place because I guess I was talking about before how programming languages get adopted because people want to write for that platform rather than any specific feature of a language.
Yeah, yeah. The other crazy idea I had related to this security thing is that okay, one reason people would want provably correct security with dependent types is if the EU regulated it.
Uh-huh.
Another would be that if we have evil AGI, then one possible threat vector by which it can attack civilization is by launching an attack similar to Stuxnet. I don't know if you're familiar with Stuxnet, but it was this like
Remind me again. It's the one with Iran where they like hacked into their nuclear facility and then was able to intermittently shut down their machines so that
yeah,
the Iranian engineers like couldn't figure out why their equipment was malfunctioning, so hence
yes,
couldn't
yeah,
really enrich uranium. That thing.
yeah, that thing that you've explained it perfectly.
Okay.
Yeah, it was basically a virus that was engineered to target that particular system, and it it made use of a lot of different like exploits to get there and infect things and whatnot. And so I think that basically a lot of infrastructure now is being computerized and digitized, like
Mhm.
the electric grid in many countries, among many other industries as well. And so uh, I wonder if there's going to be a Y2K type moment where people are like, oh, we better harden these systems because there are these unaligned AIs that could
Just out there,
exploit
right?
that are just out there that could exploit these things, right? And so and maybe it would start with maybe like state like things of national importance like electric grids, where
Hmm.
it would be terrible if somehow some evil system was able to exploit I don't know, so security issues in there, and so you would want to harden those by making them sort of provably correct.
Hmm. Yeah, I don't know. I only know of one person that works on government utilities like that, but he does transportation. I don't know about anybody in electricity. I wonder what sort of stack that they have and what their kind of development attitude is. Is it
Yeah.
that stability at all costs based on proven technologies, or do they risk doing things like, hey, some guys like, hey guys, I found out about dependent types. I think we should really look into this. Like,
Right.
I wonder, yeah, I wonder how they adopt things for their particular goals. And so yeah, I think I can see a lot of different places. Like you don't have to look far. Like even just in like what we would consider inconsequential systems like I don't know Facebook or Twitter and stuff. I mean, there's plenty of things where like I'm just sick of running into errors after error. Like I think Jonathan Blow gave a talk once about the collapse of civilization. And in it, he challenged people to make a list of all the computer errors that they run into through the course of a week. And he had to stop after a couple days because it just got to be too much.
Hmm.
And I did something similar, and the errors that I would run into before, I would just kind of shrug it off and not think about it. But like now, I do run into like I notice more. I think, and they're anything from Twitter's like incoherent caching of values on the website to like Notion not being able to indent for some reason bullet points to like when you hit the back button on YouTube, it doesn't show you the index page anymore. Like it's just like various problems. And so like I wish we had in some ways, like I mean, especially if it can help with like UX state, then like state of application programs, I think it would go a long way. And I guess like in Jonathan Blow's talk, he was just saying like the clincher was that at the hotel room that he was staying at when he gave his talk, like when he would like turn up the thermostat, like it would ring his phone a little bit. And so he could reproduce it reliably, but he has no idea like why that would ever happen. Like somehow there's some sort of coupling between the two systems. Right?
Yeah.
And so I guess this is all to say that it's in line with the idea that we're just building buildings by heaping rocks on top of each other, and it's getting worse and worse. And one of the hopes for me, I guess, is that we'll find tools to help us wrangle the heap of rocks, or at least we can find building principles so that we can build high without building wide. And to me, like math seems to be one of the good possibilities where we can find the solutions to that. Like, you know what I mean?
Yeah.
Like before we figured out how arches worked, like we had to build pyramids. Like the amount of space inside a pyramid is like tiny. Like most of that thing is rock.
Yeah.
So yeah. And like it when you don't know how to build arches, like you actually can't build very high without building really wide without rock. And so right now we're still in the age where we just pile a lot of rock based on our field. And I don't, like kind of like a design feel. And like even the things that we talk about with like the solid principle, like it's I don't know, it's a feel, right? And for some of it you can definitely do and you get good results, but they're not, it remains tacit knowledge that it makes it hard to transfer between generations, right? And so I think that's what I mean by like the tie back to like the collapse of civilization sort of thing. That hopefully like dependent types would be an example of something where we can use math that would help us build things taller without building things wider. I think that's where I was going with this.
Yeah, that makes sense. I think that one of the unfortunate aspects of working in tech, especially in sort of startups or Silicon Valley or like kind of growth stage companies, is that a lot of the people who are originally involved in designing the system or whatever tend to either move up in the sense that they very quickly, due to the growth of companies, end up becoming managers and whatnot and moving away from the code base, or they move out in that there are people who just do short stints for like a year, 2 years at companies and go. So there isn't
the
this
turnover
like,
is high.
Yeah. So there isn't this tradition where you can do some type of apprenticeship and learn from experienced trade person, right, who has been at this company working at this code base and like really knows everything and can teach you how to design with that feel or with with some principles. There's no oral tradition or whatever. And so if that's going to continue to be the case, then we either need to, like you said, keep building pyramids, right? We just throw rocks at things and make it. And that's how
rocks at things.
Yeah. So we throw people and we throw frameworks and libraries, more and more abstraction at things, or we can make use of advanced tools which are there, right? Which clearly exist, and that can help I don't know, bring some rigor, and not even just rigor, like maybe just bring simplicity, right? Like I want to view dependent types as something which will be like lift weight off of the shoulders of a programmer. I think that's the way that it's going to help, and rather than saying, "Hey, learn this other new weird thing."
It's definitely got to pull its weight
Yeah.
in order to get adoption. Because I think I think working programmers would say, yeah, I mean, provably programs are great and all, but like we got these hair on fire problems, and so I don't blame like early stage startups for acting that way, because like even beyond like correctness of programs, like the before product market fit, the overarching like the high order bit or the high order problem is like, are you building things that nobody wants? And like in order to figure that out, you do have to build more throwaway type of things because you just don't know, right? And so you can have provably correct things that nobody wants, unless like you can have provably correct product market fit. Wow, man, that would be something, right?
Right.
But there's no such
that
thing,
would be
right?
amazing.
That would be amazing. But there's no such thing, because like I think that exists outside of the nice controlled platonic solids of a computer program.
Right.
And so until then, I think that iteration, but then maybe like we need languages that are easier to refactor from a sketch into an ink and oil painting. Like usually like the early decisions somehow like get baked, and like those decisions might, like if they were more readily reversible, then maybe that'll make it easier. I don't know what you could do. Maybe ChatGPT, the refactoring version, like makes it much easier.
Right.
Something like that. Yeah.
Yeah.
So anyways, I think we kind of like bled into kind of the second and third order effect of segment of the our discussion here, where like what if dependent types were readily adopted. And so we were talking about like maybe if it was readily adopted, we could prevent the collapse of civilization.
Right.
but like did you think of like other things that would happen as a result, like with the advent of cars, the businesses that benefited weren't the automakers, but like you could have businesses like McDonald's with drive-throughs, and like a lot of the hotel chains across the US, like people travel more, or like you could have builders in the suburbs. Like what are the knock-on effects when dependent types are much more prevalent? What do you think there, Shri?
I think one thing that would be very cool is dependent types over the network. I don't know if that's a thing, but basically it would be very interesting. Like one of the visions of the web or of HTTP was this thing called like HATOS, which was that agents could interact with services, and by looking at the structure of the response, understand the semantics of how of how to interact with that service. And I think that there are many reasons why it's infeasible, but one of the reasons also I think is just it's very hard to know like what to put in the holes, right? Like okay, I have to make this response, I have to construct like some type of response. How do I make sure that I construct a value such that it is valid on the other side? And I wonder if there is some kind of dependent typing that could be transmitted across the network such that a client can know what is the universe of valid values that so as of yet unknown, like you're interacting with a new service, you haven't hard coded against that service, right? You start talking to a new service and it's able to tell you, hey, I accept this set of values, and you can construct them and know that they would be valid. And
Oh, I guess it's you're kind of going in the direction of the dream where, in order to interact with a third party API, you as the developer doesn't have to go and read up some documentation out of band to like manually program your computer to talk to their computer, so that it like self negotiates. I do know that, like we mentioned session types earlier, like session types are supposed to be types across, like types for protocols, but that's about all I know about it. And so what you're describing kind of sounds like session types, but maybe one of our listeners will be able to tell us if what you're describing is a session type.
Yeah, maybe it's a different type of type system. I don't know. Like, I think at this point, like there's such so many esoteric, distinctions between these type systems. So maybe this is not particularly about dependent types, but let's say that it is. There are certain things that dependent types can do here, right? Like sometimes, I don't know if you ever had to implement like OAuth by yourself, like the OAuth protocol. It's like, oh, pass this thing and then take the result that you get from this response and then pass it as an argument into your next request, blah, 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 blah. And I'm like, yeah, okay.
Even so using it as a library, like an existing library, is always a pain in the ass, because you're just like, this is not like the last time that I used this, and like I don't know, it's just, and then it's always arbitrary. Like whatever arbitrary decisions, it's never the same, and so you end up having to read a whole bunch of documentation and like read up on Stack Overflow to get the damn thing working, and that's just to like log in, and you're like, I haven't even started on what I was like, what this thing is supposed to do. Like logging in is table stakes. I'm here like dicking around with this thing. I'm just so angry.
Yeah, exactly. Yeah, and then after that, you have to interact with the actual API, which has its own semantics, right? Which are maybe even like poorly specified than the OAuth spec. And so, and this is for a programmer who is doing this manually, and you're reading documentation and making sure to get it all right. If we want to get to the point where we have agents that have self-negotiating protocols, self-negotiating interactions, this is a long-term interest of Alan Kay. He's like in his Hacker News thread, which I bring up at almost every episode. This is what he's looking towards.
Sure, it's for the things that we talk about all the time, honestly.
So this is one of his he's moved on past small talk. Everyone asks him about, how can we get small talk and whatever tools for thought more popular, and he's like, I've moved on to like self-negotiating agents. But yeah, I mean, I think that in previous episodes we've talked about how AI agents could be self-negotiating by reading documentation and understanding the semantics of the system. But here, I think maybe dependent types. If you had some type of dependent typing that could be exposed at a protocol level, then that could also simplify things.
So then it would be like you declare invariance of what it takes in and what it comes out. I guess yeah, I mean,
like
it seems conceivable. I mean, if you stretch it a little bit, because like you can, like if instead of the types as types, you can think of them as declaring some sort of state machine with transitions for a protocol, then maybe I guess how would you ask and traverse that? Are you picturing something like HATOS, where the traversal is universally understood, but the states and like the next states would all be sent along in the protocol?
Yeah, I mean, even at the value level, like let's assume that you have some type of payments API or something And a payments API, you interact with it maybe by passing in a user ID, and you get back a transaction ID. And then you make a follow-up call with that transaction ID that in which you add some other stuff.
I see what you're saying. Yeah. And so you get the next available action along with the response of what you just did. And then so if you had something like dependent types, it can also constrain the parameters of what you're doing, not just the coarse grain action.
Right. And so it's like, okay, about, the next call that you make this argument must be the transaction ID that was generated by the user that you passed in the original call or something like this, which you wouldn't like if you just had simple typing, all you would know is, oh, transaction ID must be a string or something like this, right? You have no idea this could be anything.
Yeah, you don't know what range it should be, right? And so that could change depending on like whatever HATOS state that you were in, right?
Right. And so, with dependent types, you can say, well, this must be this value that was derived in this particular way, right? And then it would be a valid request. Otherwise, it won't be. And so, like HATOS, right? In the absence of this, you have no idea, right? Like, what the hell identifier should I pass here? This can be anything. Whereas here with dependent typing, it helps you maybe reason about like what would be a valid value.
My hope is that there would be a standardized zoo or a library of dependent types for common API calls then. So like instead of like a different semantic for searching or posting something, like even like ActivityPub, right, that we covered recently, if you had similar semantics, then you could just use that mathematical semantic and just apply it across the board, across any API, because that's kind of the standard that people have adopted to. So like,
right.
And maybe even better if it worked in DevOps too, that same idea that you can, like, for some sort of job to be done that we often do, like if I want to search through some third-party API, like there's a common set of math objects in the same way that we have like functor maps and applicative maps for like monads. Like those are common interfaces and mathematical objects for those things. Like we have something for like common API actions that you could take, then you could apply it across the board for any API. And so then maybe documentation would actually go away because it would be known what sort of operations you could take against an API, because it would be self-negotiated and self-discovered.
Yeah, that would be cool, and I could see it being useful also in things like you said, ActivityPub, which is this like federated protocol in which I think people can add different extensions to such a protocol, and so maybe you could have clients that learn, given some, when they're interacting with something on the other side, which speaks like an extension which the client hasn't necessarily been coded to know already, maybe it could learn the semantics of the data that's incoming or the data that it should send.
Yeah, maybe. I mean, one of our viewers that might know, that knows more than us, can tell us whether this, like, we're on the mark or we're completely off the mark here.
Crazy.
But I mean, that is the one dream. So yeah, I mean, so like maybe with these sort of things, you would get self-negotiating APIs, and you won't need to employ nearly as many developers doing integration work and can actually work on the actual app that they're working on. Zapier would be a company of 10 people.
Right.
And then, I don't know. Maybe if software was more reliable, we would just have less programmers. Do you think that would be the case?
It seems like that would be the case, but I feel like they would just induce demand for more things,
For more doing other things, I guess.
doing other things. Yeah, yeah. I
Because
mean, I
there's
guess
no
going back to
shortage
your
of idea people. There's plenty of non-technical founders that are ideas people. Is that what you're saying?
no, no. I think that going back to your pyramids thing, right? Like, okay, if we're spending all this effort building like pyramids, and we're all just hauling rocks around, then once we can build skyscrapers or we can reliably just build structures without so many people and so much labor expended, then uh, then we just build more things. But I don't know. That's a hard case to make because we're already building a lot of software. So is
Yeah.
like if we got all the correctness right and it became very simple, would we build even more software? Or yeah, maybe we would just have fewer programmers. I could see it going either way.
Yeah, I honestly could see it going in either way, too. And I guess, do you think life would be better for users? I mean, like, there's plenty of frustration with how computers kind of work today, but do you think like some of that frustration would actually go away when we have some amount of correctness in our software?
Yeah,
Or maybe, yeah, I don't know.
I mean, I think that part of the reason why computers are annoying is that they seem like I think a lot of end users feel really stupid because they can't get things to work. But it's not that they're stupid; it's that the programs are stupid. And people who know about computers are able to be like, "Oh yeah, the program is being stupid. Like we're just going to restart it," or like, "Oh, it was stupid in this way, and we just have to like get it back into the way that it was before." But I think that I think most people don't have that mental model, and so they feel very frustrated by software. And so yeah, I mean, I could see that it's like it would improve things a little bit of the user experience, but I do also wonder whether it'd be a huge step change because the things that I'm thinking about are like, oh, you have to restart your Wi-Fi because it randomly stopped working, or you have to restart the printer
Hmm.
because you sent a print job and then hit cancel and then now it's like become
Right.
unresponsive or something, right? And it's like,
Right. Yeah.
okay, but like what's the downside there? It's fairly bounded. Like you just have to restart the printer. It's not like the worst thing in the world.
Well,
So
sometimes you're running out the door because, like, I don't know, like, I have plenty of times where I just need the freaking ass thing to print right now because I'm trying to head out the door. It just won't
right.
work. I'm just like, oh, this, yeah. I don't know. Like,
Yeah.
those are, yeah. But then I don't know. Like I'm thinking like downstream consequences. Some of that is hard to say. Like I could just wave my hand saying maybe all the anxiety in the world is caused not just by the climate change and the geopolitical stuff going on, but just the fact that we're surrounded by machines that willfully just break and
Right.
is just dumb all the time. I don't know. That's all hard to say too.
Yeah, I think that the stakes are pretty low with just like consumer level stuff.
Yeah,
I would
yeah.
say like
Well, I would say that it's probably the when it comes to consumer level stuff, it would be the distributed systems of the people that are maintaining those things that it
yeah.
would be the most beneficial for. But then, are you saying there are other classes? I'm guessing.
Yeah, I mean I think just like we already talked about it, but just like in terms of uh
Yeah.
security and running
Hmm.
distributed systems
Yeah.
like you said,
Right.
those are the ones where they're kind of behind the scenes, but you want to make sure that they're right. Otherwise, you end up with outages and data loss and whatever other types of issues. And I think people do care about those. They might not view those as like, oh, that was a software problem, and and now my life, like they might not be aware, oh, my
Yeah.
life was affected by software bugs, and correctness would have helped that. But they do know, they do feel the consequences.
So if you can't tell, I'm like taking stabs in the dark, but I think I was trying to say think of like if this thing, like if we get correct software and stuff, like what happens as a result of that?
Yeah. What would happen? What would happen if we got a lot of if all software was correct? No, I think this is one of the cases where it's like, yeah, there are things that wouldn't happen, and by preventing them, no one would notice because it's hard to prove. It's hard to demonstrate that you prevented something from happening, right?
Yeah. That's why there's certain jobs that go unappreciated. But then maybe
Yeah.
an analogy to think about this is like we are in ancient Egypt and we're like, what if we had arches? Like we know that we would stop, like would we employ more slaves or less slaves? Or
Right.
like, like would we have more, like what would happen, like? And so maybe an analogy there is like we look at all the things that we could build, and so instead of just like pyramids as like giant tombs for rulers, the number of use cases would blossom into living spaces for a variety of people and for a variety of use cases, like for, I don't know, like commerce or like
Mm-hmm.
office space, right? And so
Yeah.
maybe absent of a job to be done, this is really hard to picture, right?
Yeah. Yeah.
But I guess that's as far as I can go at the moment, in some way to think about like what would happen if software was mostly correct and could check itself at compile time.
Yeah.
Like you would get new stuff that you could do with more ease.
Yeah, but it's very hard. It's actually really hard for me to imagine what, because it's actually so far from like my experience.
Yeah,
Uh,
yeah. Well, also, it's kind of like, to draw the analogy again, like we're in ancient Egypt. We're like trying to imagine a skyscraper.
yeah.
Like office jobs don't yet exist, and we're like, why? Like we can't imagine like why somebody would want to build a really tall building other than maybe for worship, right?
Right. Right.
And so like we're like, oh, so people in the future are going to drive to this building to go up the stairs or like the elevator, if they can conceive of an elevator, and like
Right.
sit there for 8 hours a day at desks, and in the 1900s, like write on pieces of paper or type on it or dictate to somebody else to type. And
Yeah.
nowadays it's like computers like
Yeah.
sitting there, like it's just a little bit hard to conceive. And so what we're missing, I think, is kind of the job to be done of the future, like that it's tied in with like something else. Like if we had some idea of like how people might live in the future, then maybe we can conceive of how like the new kinds of software we can make correct by construction, like what that would enable.
Mm-hmm. Mm-hmm. Yeah.
I don't know. Do you think it would help
Or
people build like large language models more easily or correctly, or is that not really a consequence of the actual machine learning and inference engine, but more as a consequence of the data that you feed it?
yeah, I think the LLM or just training a ML models generally is less to do with the code and more to do with
The
the
data, right?
training. Yeah, like how you train it. Although I could see that. Yeah, I think it's just like going back to the AI generated code thing. Like maybe instead of what we were talking about with the cucumber and the PM now being able to write a specification that the engineer uh, implements, like if you just have like a code writer AI, then yeah, your idea guy slash PM would write some invariants that matter, the business invariants, and then that gets turned into dependent type somehow. And if you had the code copilot model that was somehow aware of dependent typing and could maybe even use the type checker, the dependent type checker, as a tool that gives feedback, then you, as an output, get provably correct code, right? And so right now with this kind of copilot models or whatever, like these code assistant models, they're purely for assistance. You can't just like toss in some input, get back something, and like know that it was right. Like you still need like somebody to go and like look at that and make sure it did the right thing. But maybe with dependent types, there are certain class of problems where you are comfortable enough being like, yeah, okay, the AI, like it type checked and like the AI wrote it, and we're just going to use it.
You know, in that sense, then maybe one knockoff effect, like second, third order effect, is that the pipeline from basic sciences and core sciences to end user application in industry will be significantly shortened, because once you have like some provable math concept or discovered physics concept, you can readily transform that into a working program that then you can apply. So that might accelerate technological advancement as a result, because right now it takes decades for that stuff to filter through, right?
And the bottleneck there is that converting those basic science principles into like implementing them in some system takes a long time, or it takes a lot of effort.
Right. Well, because they work in different worlds. Because like right now, a lot of the mathematicians or even like physicists, they work in different tools. Like mathematicians are using proof assistants, and like physicists are using Mathematica, or like things that you wouldn't, like working programmers wouldn't use as implementation tools or ecosystems. And so maybe with something like dependent types where programs are proofs, then even if somebody wrote something in Coq or Agda, like it's readily transformable. Like you can even use ChatGPT to do a one-to-one transformation between that and some other, I don't know, C++ with dependent types or something like that. And so the pipeline between basic science and industry implementation would be much shorter, and so that would accelerate like technological advancement. Maybe that would be like maybe that would be possible.
Yeah, I was thinking in a different science application, actually. So I once worked in a research lab that was doing synthetic biology research. And the way that they framed the problem is that we were trying to find some sequence of operations that proteins could perform that convert some input chemical into some intermediate chemical, and then keep converting those until we get some output chemical. And what we used was this library that did simulations, not simulations. It basically had a set of rules about how, like, given two chemicals A and B, like how they would interact and whether they would produce like chemical C.
You're right.
And so what we did was we took all these research papers that showed like, oh yeah, this is this reaction and this is how it worked, and we converted those into basically some type of like knowledge base, and we had some solver that would generate like a path through this graph of chemicals to find like the sequence of things that would convert like one chemical into another. And that seems like something that you could in fact use maybe like dependent types for, in that there's some semantics of the problem space, right? Like the semantics of the problem space are like you have chemicals, and certain chemicals are valid inputs to certain reactions, and some are not. And that, I wonder if you encoded those, as types, whether you could have this elusive like chemistry programming language, like a chemistry DSL, in which you are working with like your types are the chemicals, right? And you're writing like equations, or you're trying to synthesize a program, which is a sequence of equations or reactions, and the type checker helps you like maybe it could be helpful for like drug synthesis or like something in which you have a search space, and you have some rules that you need to encode about what are valid inputs to like reactions.
I wonder if the list of dependent type constraints would be so complicated that you wouldn't actually program that as a human, but you would just feed it into ChatGPT so that it doesn't have to learn all these things itself. Or maybe the rules are generated by ChatGPT, like it's some GPT like thing, right? Because in a previous episode we talked about how like maybe GPTs, these large language models, can from a large amount of unstructured data be able to synthesize structured rules, or like synthesize it into structured data, and so like relationships between these sort of things. And so maybe it can generate this like type system for a protein chemistry. Is it chemistry or proteins?
It was both in this case, but yeah.
Oh, I see. Yeah, like that it would be able to give, but not to a human, but to another subsystem, whether it's like a large language model or not, to be able to improve its capabilities to find. Because like I guess if you handed it raw, so I think GPTs and large language models can do it nowadays, but I wonder if the efficiency can be improved if you develop the type system for it. Or maybe this is the equivalent of like, why have that intermediate step when you can do it all in one shot? And thinking out loud, the only reason I can think of is that maybe it's like an intermediate representation that you want to farm out to different subsystems and not just LLMs. Like maybe LLMs can do it, but they're inefficient, so you want to throw it at a Z3 solver or something like that.
Yeah. I mean, I think that, yes, it does sound like there are some cases where we're like, oh, we should add some structure that helps humans, but in fact, the models don't actually need this structure at all, right? Like, we don't need to parse like the sentences and add part of speech tags to pass into the thing, right? Like, it doesn't care about that. But I do think that there are some, I think there is interest in getting LLMs to interact with tools, right? Have general purpose LLMs that like interact with tools in order to solve sub problems for part of large problems. And so in that case, rather than always,
because LLMs aren't great at everything, right?
Yeah. Right. And so rather than always having to fine tune an LLM that knows how the semantics of how chemicals work and every other random thing works, if you were able to encode those rules, certain of those rules as types, and you use proof assistance and dependent type checkers, then the LLM can do the part about reasoning, and the type checker can do the part about checking for correctness.
Yeah, because sometimes you don't know whether these LLMs are just making stuff up or just lying to you, right? Yeah. So I think that's kind of the where we're at with the thing. I think we've kind of gone as far as our imagination could take us. Like I think we would have to like imagine use cases of the future, and we know we'd be wrong, because like definitely you can see in the retro future commercials where people imagine there would be a computer in every kitchen where stay-at-home moms are flipping registers in a computer, which obviously is not what we have today. And so I think we've kind of gone as far as we can go given the limits of what we know about the future today. What do you think?
Yeah, I think so.
Mm. Yeah. So with that, like, how do you feel about dependent types? Like, did you come into it pretty optimistic, saying, "Yeah, this there's something here," or is it more like your feelings about some of our other topics where you had to have your mind changed?
Yeah, this one actually, I could see like the immediate uses. It took a while to get past the mathiness of it and also get past the silly toy examples. But yeah, I could see
Yeah.
it, and I could especially see it if this was added progressively into languages that are, I'm already using, rather than having to go wholesale into a very obscure language that nobody knows.
Mm-hmm. Yeah, I think for me, my enthusiasm is high for the things that are known to be hard for humans to wrap their brains around, namely things that are around distributed and concurrent systems. So I really like the experience of using it as well, where you get to like fill in the holes, and it feels iteratively fun, kind of like you actually have an assistant. Like you still have to direct things, and so maybe something where it's both Copilot and Agda at the same time, that gives you even less to do, and all you have to do is like start picking things. Like maybe you can actually program on an iPad if you had both Copilot and like these proof assistants running. So that would be interesting. So yeah, with that, I would say my enthusiasm and optimism is, in fact, out of this world, but it would have to be a very slow rocket, because I think even 15 to 20 years later, I think we'll start to see adoption in mainstream programming and programming languages, because this stuff definitely moves slow.
We can't hold our breath. Yeah.
Right, exactly. And so with that, I think you know where our stance is. And if this episode opened your eyes, check out our other episodes where we talk about the other edges of technology, why they're interesting, and what future they point to. Check them out and subscribe. And be sure to check out our audio versions on Apple Podcasts or Spotify, and write us a review to help bring other Techniumistas on board. And with that, this is Will.
And this is Sri.
Signing off, and we'll see you next time on the Technium. Take care. Bye-bye.